Find the sum of all multiples of 7 lying between 300 and 700. Right? We'll be solving this sum with the help of concepts of arithmetic progression, right? So first let's figure out what are the multiples of 7 between 300 and 700. If I am to, let's just do that in a rough work, right? So if I am to divide 300 by 7, I get 7 fours are 28, and then I'm left with 20, which is 7 twos are, so it's 7, and then we left with 6. So I get 42 6 upon 7. So I'm falling short by 1. So that means the first multiple of 7 greater than 300 would actually be 301, right? And so after that, the next multiple of 7 is 308. And after that, it will be 315. And after that, 322, and so on, right? I want to find the multiples of 7 less than 700, right? Because they have to lie between 300 and 700, so I cannot include 700 in that. So less than 700, the multiple of 7 is basically 693, right? 693, 7 less than that, right? So as you can see, so this is my, these are the multiples of 7. Um, multiples of 7 between 300 and 700 are 301, 308, 315, 322, and so on all the way till 300 and 693. So as you can see, this here is actually forming an arithmetic progression where the first term, so therefore this is an arithmetic progression where the first term a is equal to 301, right? Uh, common difference is obviously going to be 7 because there are multiples of 7. So the common difference, as you can see, is 7. Uh, and the last term I can say is 693. Last term is equal to 693. I want to find the sum of all of these terms. So if you guys remember, this formula for the sum of n terms in an AP is either n upon 2, 2a plus n minus 1 into d, right? Or I can say it's n upon 2, a plus l, right? Either of these formulas, I need to first figure out what is the value of n, and only then I can use them, right? So first, given this information, I will have to find the value of n, and then I can use either of these formulas and find the value of the sum of n terms. Okay, to find the value of n, I will use the formula of the general term Tn, which is a plus n minus 1 into d. And what I'll do is the last term, 693, I can consider this to be the nth term, right? I can consider this to be the nth term. And if I find the value of n here, I know what is the position of this term, and so I know the number of terms in the entire series. So as I just discussed, the formula for the general term Tn is equal to a plus n minus 1 into d. So a plus n minus 1 into d. Right, we already know this. So let's just start plugging in the values so that I can find the value of n. So I know L is the nth term, is also the last term, so that is 693. So 693 is equal to a, I know here is 301 plus n minus 1 into d. N is the unknown over here, so n minus 1 into d I know is 7. Let's rearrange, take the 301 from the right to the left. So it becomes negative minus. So 693 minus 301 will make it 392 equal to n minus 1, n minus 1 into 7. 7 is getting multiplied here, taken to the other side becomes division. 392 upon 7 will give me 56, right? 56 is equal to n minus 1. Rearranging this, I get the value of n as 57. So there are 57 multiples of 7 between 300 and 700. So these are all the multiples that we just found. Now I know there are 53 terms. I know this last term is the 57 terms. I know this last term 693 is the 57th term. So I will use the SN formula, which is Sn is equal to n upon 2 a plus L, right? The first term plus the last term. I'll use this formula where I already know all these values, so I can just start plugging them in, right? So I want to find S of 57 because I know there are 57 terms, which is equal to 57 upon 2 into A plus L. A, I know the first term is 301 plus the last term I know is 693. 693. Okay, so let's solve this and find the sum of the required sum, right? So this is 57 upon 2, and if I add these two numbers, 301 and 693, I get 994. Right, so I can cancel 2 from here. If you can see, it's 2 ones are 2 fours are 19 is 9, 14 is 7, so 497. Okay, so this is not a very pleasant calculation to do. I have S57 which I want to find, which is 497 into 57. So let's do this multiplication real quick. 7 sevens are 49, 7 nines are 63, 67, 7 fours are 28, and 6 is 34. 5 sevens are 35, 33, 5 45, 48, 4 and 5 fours are 20, 24, so 24. Right, 9, 12, 13, 4, 4, 8, so 2, 8. So the sum of 57 terms of this AP is 228,329, right? So this is what the answer I was looking for. So if I write it in a statement, the sum of all multiples of 7, right? So sum, so therefore I can say the sum of all multiples of 7 lying between 300 and 700 is 28,329. And this is my final answer, right? So 28,329. It's my final answer, which I will put in my final answer rectangle.